In this lesson, we're going to look at a different way to measure angles, and that is using radians. So this is called Radian Measure. And so we start with a circle that has a radius of r. So the radius, so the length of the distance from the center to the edge is r. If we use that length to measure an arc along the circle, so I've got that length r and I start here, we'll call this the initial ray of the angle. If I measure an arc, that's the same length as r, and put my terminal angle of terminal arm of the angle there. So if I measure that angle, that is 1 radian. So a radian is equal to the measure of the central angle of a circle that intercepts an arc equal to the radius of the circle. Okay, so 1 radian is the angle that you get when you've gone along the edge of the circle the measurement of 1 radius of that circle. So it doesn't depend on the size of the circle. A small circle will have a small radius. The angle will be the same, whatever size that circle is. So if we want to measure something in radians, it's the length of the arc divided by the radius of the circle. Okay, so it's the length of the arc divided by the radius of the circle. So if I do, for instance, this angle, and I measure the arc, and I recognize that I've gone 1 radius, 2 radii, and let's say exactly 3 radiuses. So all of these arcs are the length of 1 radius. And we'll use, let's use gamma for this angle. We can say that angle gamma is equal to 3 radiuses. Remember, r represents the length of our radius, divided by the radius. So 3 radians. Okay, because I've gone 3 radiuses is the length of the arc that this angle makes. The angle is given as 3 radians. You're going to learn a lot of symbols representing lengths and angles over the next few days. So it's really important. Maybe you want to start your own sheet with vocabulary and so forth on it so that you can refer to that regularly. So for any arc length S, okay, so S is the length of an arc. The angle, so theta is an angle. Angle theta is equal to S divided by R. So S is the length of the arc. R is the length of the radius. Okay, so in this example, question 1 here, I've got the angle theta in my circle. I've been given that the radius is 8 centimeters. The length of the arc made by that angle, S, is 20 centimeters. So my angle alpha is going to be 20 centimeters over 8 centimeters, which gives me 2.5 radians. Let's look at another example. The minute hand of a clock is 7 inches long. During class, it has moved through 30 inches. What is the central angle? So our central angle is the length of the arc. Let me fix that theta up there. The length of the arc is 30 inches. It's the minute hand has moved 30 inches around the circle, and the radius is 7 inches of the minute hand. So that gives us 4 2/7 radians as the measure of the angle. let's continue on with this. How many radians would there be in a full rotation? So if I were to go all the way around and end up in the same spot, how many radians would that angle be? So if you think about the formula that the angle is equal to the arc divided by the radius, how long is the arc? So remember, think about it. We're going around the circle. What is the formula for the distance around the circle? If you think about it in terms of the radius of the circle, you may remember that the distance around a circle is 2 times pi times the radius. So the distance, the s, the distance around the circle is 2 pi r. Divide by the radius. Notice that we've got radius divided by radius. So we get 2 pi. So 2 pi radians is one full rotation. Now, if you recall from earlier when we were talking about degrees, a full rotation is 360 degrees. So I've got 360 degrees is equal to 2 pi radians. So if we divide both of those by 2, we'll have 180 degrees, or a straight angle, or half a rotation, is equal to pi radians. It's useful to think of this now in terms of rearranging this so that if I take this final equation here and divide both sides, for instance, by 180, I'll have 1 equals pi radians divided by 180 degrees. Or if I divide both of these sides by pi radians, I'll get 180 degrees divided by pi radians is also equal to 1. This will come in very useful in a few seconds. Notice that from the examples that we did earlier, when we started talking about radians, we gave those answers as fractions and not decimals, and that is the standard. When we're talking radians, we never use decimals, we always use fractions and give exact values. So let's practice now converting between radians and degrees, because our goal is for you to be able to think in terms of radians as opposed to degrees. As we go through trigonometry, we're going to be using degrees a lot of the time, but there are also a lot of times when we're using radians, and so it's important to get a real feel for how many radians an angle is. So if I'm starting with degrees, in this example where I've got 45 degrees, remember if I multiply by 1, I don't change the value. Well, on the previous slide, you'll notice that I said that 1 was equal to pi radians over 180 degrees. So 45 degrees times pi radians over 180 degrees. Notice that my degrees cancel out. And I now have 45 pi radians over 180, but 45 and 180 can be simplified to 1/4. So I have pi over 4 radians. Likewise, negative 120 degrees, I take the negative 120 degrees, I multiply by pi radians over 180 degrees. The degrees cancel out, and I simplify the numbers as much as I can. So 120 over 180 is 2/3, and it'll be a negative 2/3. So this is negative 2/3 pi radians, or 2 pi over 3 radians. And this is the standard way that we write that. We include the pi in the numerator. Switching from radians to degrees, we just do the same thing. We take the 3 pi over 8 radians, and we multiply by the reciprocal of what we did previously. So we multiply by 180 degrees over pi radians, And notice that the pi radians now cancel out. And I've got 3 times 180 over 8. And I simplify that as much as I can. And I have now 67.5 degrees. So we'll try the last one here. Remember, you can always press pause, try the answer yourself, and then um, uh, press play again and check your answer. So I've got negative 2 pi over 3, and I'm going to quit writing radians down each time, times 180 over pi. So my pi's cancel out, and I've got the 3 goes into the 180 6 times, so I'm going to have 60 times, so negative 2 times 60, so negative 120 degrees. And I believe there's one more question down here. I've got 1 radian. So let's see how many degrees 1 radian is equal to. And we're going to use our calculators for this and give an approximate answer, but I'll have 1 radian times 180 degrees over pi. So I'll just do 1 times 180 divided by pi, and I get approximately 57.3 degrees. So the trick here, if I'm going from degrees to radians, because I want to get rid of the degrees, think about putting the degrees in the denominator then. So I multiply by pi over 180. To go from radians to degrees, I want to get rid of the radians, so I want them in the denominator, so I multiply by 180 over pi. Okay, so it's pretty straightforward to do the switches. You really need to be comfortable with fractions and simplify them, and we usually leave them in improper but simplified fraction form. So now we want to start thinking in terms of radians when we're working with the Cartesian plane. And I've uploaded a sheet that has circles on the Cartesian plane with little hash marks on them for where we've split the circle into eighths and into twelfths so that you can very precisely draw almost every sketch, almost every angle that you see. So you may like to print that for yourself. I will also make sure that there are pages of that in the classroom for you to use. So we want to draw these angles in standard position. We don't want to think in terms of degrees. So get that out of your mind, and we want to think in terms of radians only. So I've got theta is equal to pi over 4. So that's a quarter of pi. And remember that pi radians, there's 2 pi radians in a full rotation. Pi radians is a half of a rotation, so it would get you to the negative x-axis. So we're doing pi over 4, or 1/4 pi. So that's 1/4 of the way from the positive x-axis to the negative x-axis. So that will get you right in the middle here. So there's pi over 4 radians. Okay, so you can think of it as pi over 4 is 1/8 of 2 pi, which is a full rotation. So it's an eighth of a rotation, or it's a quarter of going halfway around. Okay, it's very helpful to remember that going, and I'll just show it in blue, going halfway around gives me pi radians. So pi over 4 is a quarter of that. Okay. So if we look at B, I want 5/4 of pi rotations. So you may want to think in terms of going 5/4 of pi rotations. So I'm going, here's 4/4, and so 5/4 is 1/4 more. Okay, so it's exactly halfway between the negative x and the negative y rotation there. And we'll call that angle alpha. and we're showing it as a positive angle by putting an arrow on that rotation. Okay, question C asks us to do a negative angle, and it's negative 3/4 pi. And again, so our initial angle is still here, the initial ray of the angle, but now we're going clockwise. So we're going to start by going down, and we're going 3/4 of pi. Remember, pi is halfway around, so we're going to go 3/4 around. So we're going to end there. Again, halfway between the negative x and the negative y axis, and we show our direction of rotation as being negative, and we'll call that beta. And our final example here is gamma is 9/4 pi. So if you think about 9/4, that is 2 1/4. So 2 pi is a full rotation, plus we're going one more quarter. So we're starting along the positive x-axis, and we're going to do a full rotation plus 1/4 of a pi more, and there's gamma. Okay, and this little coil shows the direction of the rotation. It shows that we've gone all the way around once and 1/4 pi rotation further. If you look at examples C and B, notice that they both ended at the same spot. Okay, the 5 pi over 4 ended up halfway between the negative x and y axes, and the negative 3 pi over 4 ended up in exactly the same spot. These are called coterminal angles. They have the same terminal arm on both angles. So for angles measured in degrees, if you think about it, that means that we could go, if we start at an angle, we could go a full rotation more or a full rotation less multiple times and end up at the same spot. So for angles measured in degrees, theta, whatever the angle is, plus or minus 360 degrees times k, where k is an integer, gives us a coterminal angle. So we can substitute k with any number, positive or negative, any whole positive number or its opposite, and end up at the same spot. If we're measuring our angles in radians, adding 2 pi rotations, so adding any number of full rotations will give us a coterminal angle. So let's just practice that with a couple of questions here. So if I have 3 angles coterminal to 50 degrees, well, we can start with, let's do one of them being 50 plus 360 degrees times, well, let's just use 1 for k, for example. So that will give us 410 degrees. So the angle 410 degrees will end at the same spot. It'll have the same terminal arm as 50 degrees will. We can also subtract, remember, so we could say 50 minus 360 degrees times 6, and you can whip out your calculators if you like, or you can trust me, and that'll give me negative 2,110 degrees. Or we could go 50 plus 360 degrees times negative 1. Remember, k can be an integer, and that'll give us negative 310 degrees. So all of these angles are coterminal to each other, which means that they all will land in the same spot, in the same quadrant. Okay, so now let's practice with our radian measurers. Okay, they're a little bit trickier. If we use, we want angles that are coterminal to 5 pi over 8. So we can say, well, let's try 5 pi over 8 plus 2 pi times 1. So if you can, in your head, turn that 2 pi into eighths. Well, 1 pi will be 8 eighths, so 2 pi will be 16 eighths. So that will give me 16 eighths plus 5 eighths, 21 eighths pi. radians. Okay, so 21/8 or 21 pi over 8 will land in the same spot. We'll have the same coterminal angle as 5 pi over 8. So we can also do 5 pi over 8, for instance, minus 2 pi over 1. So that's minus 16/8. So that'll give us negative 13 pi over 8. And we could say 5 pi over 8 plus 2 pi times 4, for instance. So remember, 2 pi is 16/8 times 4 will give me 64/8. 64/8 plus 5/8 gives me 69 pi over 8 radians. And that's it for this very long lesson introducing you to radian measure. Be sure to practice as many of the homework questions as you can so that you really are sure of learning this terminology. You'll see that you'll be using this a lot for the next few weeks.